Next lab. Okay, so again, 122. This lab is going to be looking at. It's called determination. Well, let's see. It's called determination of a rate law. So we cover rates, and what we're going to do is find out some equation. It'll be K, which is rate constant, is equal to, rate is equal to K, the rate constant, times the concentration of the reactants to their appropriate power order. So what we're going to do is we're going to determine that order. So we're going to determine the exponent, and we're going to determine K, and then okay, the K. All right. And the way we're going to do that is that we'll have different concentrations. We'll have different rates because of different concentrations, just like we did in the experiments. You remember where we had we held one, like A plus B gives me C, and then we held A constant and changed, maybe doubled B and looked at what happened to the rate. And then we did the same thing with B. We held B constant, and then and look what happened to A as we changed it and what happened to rate. And then from that you can find the rate constants and then the orders. Okay, so so there's going to be two experiments here. The first one is going to be determining. Let's see. Okay. All right. So we're going to be determining the rate law, the first experiment, and then the second experiment. We are going to be determining the activation, the energy of activation. Okay. So. And we're going to have to use different temperatures for that. I may skip that one, but depends on if I have. What I need to do is at 3 temperatures, and determining my time here. If I can do all 3 temperatures, I will. So the first experiment, what I'm going to do is that I make 7 solutions. Then what we're going to do is watch their change. How fast it takes them to change. Normally I would really like some help with this because it's hard to watch and keep track of a clock while you do this. And then the second experiment is actually coming up with the rate, the energy of activations. Okay, so. So I want to do A first, so I make 7 different solutions, and then see how long they take. Okay, so the 7 solutions are all going to be similar. Is that they're going to all have? Okay, so I have 7 test tubes here, and it's each test tube, and I'll send you the lab procedure. And each one of them have the ionized water buffer, acetic acetate buffer, a 0.30 molar concentration of potassium iodide, a 0.020 molar of sodium thiocyanate, that's Na2S2O3, 5 drops of starch, and then 0.1 molar H2O2. Now there are going to be varying amounts of each one of them. So I'm going to set it up. So what I'm going to do is in each one of the test tubes, I'm going to add the deionized water buffer, potassium iodide, the sodium thiocyanate, and the starch. And then I am going to add the hydrogen peroxide to start the experiment. Okay, so I'll go up and make these into the test tubes. You see the test tubes. I'm going to go ahead and do that, and if you look at the lab procedure, you'll see like number 1, I'm going to put 3.5 mils of water, 1.0 mils of buffer. In fact, all of them get 1 mil of buffer. Third one gets 1 mil of potassium iodide, 1 mil of sodium thiocyanic, 5 drops, 3.0 mils of hydrogen peroxide. All of the 10 test tubes will have 10 mils of solution when we're all done. Okay, so I'll set them up, and then I'll actually do, after I get them all ready except for the hydrogen peroxide, I'll start the next video up. Okay.